Imagine a massive cargo ship miles from shore, carrying goods critical to global supply chains.
What keeps its incredibly complex machinery running smoothly day in and day out, preventing catastrophic breakdowns? You might picture, I don't know, a team of engineers running on caffeine, maybe some duct tape involved.
Well, thankfully, it's a bit more sophisticated than that.
It's really a highly structured, meticulously planned approach to taking care of the ship, making sure those critical engines just keep running.
And that's exactly where we're dropping anchor today. Maintenance systems, or PMS in marine engineering.
It's basically the playbook that shifts shipboard maintenance from just reacting to problems. That whole chaotic fix it when it breaks thing.
Right, the firefighting mode.
Exactly. To proactively intervening, getting ahead of issues before they happen. So our mission for this deep dive is really to give you a shortcut to understanding this critical, often kind of hidden cornerstone of safe and efficient maritime operations.
Yeah, and we're going to dig into some maybe surprising facts and give you practical insights.
And what we're focusing on here in marine engineering, the basic ideas, systematic maintenance, managing risk smartly, using data, they're pretty universal.
Oh, absolutely.
We could apply them to almost any complex system. Really think IT infrastructure, city planning, even your own business processes.
Okay, let's unpack this then. So what can you expect?
Today we're going to trace how maintenance evolved from basic fixes to these really sophisticated digital systems. We'll look at why regulations demand this proactive approach, how it actually gets done on a ship, and where the cutting-edge tech is taking it all. Ready to dive in?
Let's do it. So at its heart, systematic maintenance isn't just nice to have.
It's truly the foundation, the bedrock of safe and efficient maritime operations. A good PMS actively reduces operational risk and crucially protects the huge investment these vessels represent.
So it's more than just keeping the ship from breaking down. What are those broader impacts?
Oh yeah, way beyond just running it. Directly leads to better, more sustained vessel performance. And super important, it ensures you're meeting all the regulations. Plus maybe the biggest thing, it seriously boosts the safety for everyone on board.
Right?
It's absolutely essential for modern shipping. I mean, think about it. An unplanned engine failure on a big container ship could cost the company upwards of $200,000 a day.
Wow.
In lost revenue, emergency repairs. That's the kind of chaos you risk without a solid system.
Okay, yeah. That figure really puts it in perspective. And thinking about those costs, it makes sense that it wasn't always this planned out. What did maintenance look like way back when?
Yeah, it was a completely different world. Historically, maintenance was often what we call corrective or just breakdown maintenance. You basically waited for something to fail spectacularly before you did anything about it. Like waiting for your car engine to completely seize before even thinking about an oil change.
Which sounds incredibly stressful and expensive. I can just picture the unpredictable delays, the massive repair bills, not to mention the safety risks. As ships got more complex, more automated, that reactive stuff just couldn't cut it anymore.
Right? Exactly right. The industry, maybe a bit slowly at first, started shifting towards more organized ways. Early attempts involved basic paper logs, maybe checklists, mainly just to satisfy the surveyor.
Just tick in boxes, pretty much.
But then, as you'd expect, digital tech came along and changed the game. That really paved the way for the modern digital PMS we see now. Systems that could actually link different things together, moving way beyond stacks of paper.
Okay, so we've seen the messy past. How has PMS really changed the game for safety and operations today? Let's dig into that significance. Safety compliance and operations. Safety first.
Well, scheduled checks replacing parts before they fail dramatically cuts the chances of equipment breaking down unexpectedly. We're talking about preventing really critical failures like losing steering in bad weather or an oil spill from a busted pipe.
Yeah, nightmare scenario.
Absolutely. It's vital for things like the main engine, steering gear, fire systems. A good PMS ensures these safety-critical systems are regularly checked and maintained. And crucially, there's proof it was done right.
And then there's compliance. That must be massive in shipping.
Oh, it's huge. International rules, specifically the ISM code, International Safety Management Code, are basically the global safety rulebook for ships. It flat out mandates structured maintenance.
So you have to do it.
You have to. And a well-kept PMS provides the proof, the verifiable records you absolutely need for inspections by port state control or classification societies. Without those records, you might not be allowed to sail.
That's a serious consequence. Okay, and operationally, what's a tangible benefit there?
Operationally, it means the ship is just more reliable, less unexpected downtime, and smoother schedules. You can also manage your spare parts much better and optimize inventory. All that adds up to better economic efficiency. Here's something interesting.
A ship with a really well-documented maintenance history can actually fetch a higher price when sold, maybe 10-15% more.
Really? That's significant.
Yeah, it becomes proof of good upkeep. Plus, it really helps with knowledge transfer when crews change over. The history is all there.
That knowledge transfer point seems huge. Crew changes must be disruptive. So having that system is a game changer.
Okay, let's shift gears a bit and talk about concepts. How do different ways of doing maintenance fit together in a PMS?
Right, so maintenance generally is keeping stuff working. A PMS is much more structured, systematically scheduling work and documenting it all. It's managing equipment health proactively, not just reacting when something breaks down.
So within that proactive approach, what are the main strategies? You mentioned corrective earlier.
Yeah. First is corrective maintenance, the "oh fix it when it breaks" approach. Simple idea but costly downtime and emergency repairs. Purely reactive.
Okay, so the first step away from pure reaction would be preventive maintenance?
Exactly. This is where you schedule work before something is expected to fail. Regular inspections, changing oil, replacing parts based on time or usage hours.
Right, like the sticker on your car windshield.
Exactly like that. The goal is to stop unexpected breakdowns and hopefully make things last longer by catching problems early.
And then there's predictive maintenance, PDM. How's that different?
PDM is cutting edge. It uses condition monitoring sensors, tracking vibration, temperature, oil quality, etc. Algorithms analyze this real-time data to spot subtle signs of wear and tear and forecast when a failure might come. Maintenance happens exactly when needed.
So it's super optimized, like the machine telling you when it needs attention based on actual condition rather than calendar time.
Precisely, it avoids doing work too early or too late.
Okay, so you don't necessarily choose just one approach?
Nope. An effective PMS blends all three: corrective for some things, preventive for others, predictive where it makes sense.
That adaptability is key. Tailoring strategy based on equipment criticality, cost involved, and available technology. That's what allowed PMS to grow from paper logs to complex digital platforms.
Yeah, that evolution itself is fascinating, moving from paper to pixels.
Totally. We started with physical logbooks and wall charts. Imagine tracking everything on a huge ship that way.
Prone to errors and hard to update. Nightmare to find info later.
Then came first-gen digital systems, standalone computerized maintenance management systems, CMMS, big improvement, better data storage, and easier reporting, like going from paper ledgers to a basic database.
And now?
Now the trend is fully integrated digital platforms combining maintenance, inventory, purchasing, even safety procedures all in one place.
So everything talks to everything else.
Exactly. Better data consistency and smoother workflows. A holistic view of ship operations.
What core functions do modern systems provide?
Key functions include scheduling precise tasks, inspections, preventive jobs, overhauls based on time or running hours, documentation, every action recorded, creating auditable history, and resource management, ensuring right people, tools, and spare parts are available.
How does resource management work?
The PMS links directly to inventory systems, checking stock levels when jobs are planned, updating counts when parts are used, triggering reorder requests automatically when supplies run low.
That streamlines supply chain and avoids delays from missing parts.
Exactly. Saves time and money by minimizing delays and optimizing spare quantities on board.
Zooming out, what's overall impact?
Biggest payoff, enhanced reliability. Fewer breakdowns mean more operating time and revenue. Sticking to schedules is huge.
And safety?
Definitely improves safety. Reliable equipment means fewer dangerous situations at sea. Protects crew, ship, cargo, and environment.
Lifecycle cost optimization?
By doing timely maintenance, you extend machinery life and reduce expensive emergency repairs, lowering total ownership cost over vessel lifetime.
What about human factors?
Standardized procedures and checklists reduce ambiguity and human error on complex tasks. Acts as central knowledge base holding history and best practices, invaluable for continuity during crew changes.
It's like digitizing the ship's institutional memory.
Exactly.
Not all smooth sailing, though. Common challenges?
Technical, compatibility issues between PMS and other ship systems, cybersecurity risks, especially if cloud-based or networked, need strong protections for data integrity.
A cyber attack on maintenance system could be devastating.
Absolutely.
Human side, user resistance due to unfamiliarity or seeing PMS as extra admin work. Lack of training worsens this problem.
How do companies overcome hurdles?
On tech side, robust backup recovery plans, strong access controls, data validation, cybersecurity measures like firewalls and encryption with regular updates.
On human side,
Communication is key, explaining why PMS matters. Thorough training, ongoing support, demonstrating benefits, fostering teamwork across departments.
makes sense.
Looking forward, where is PMS heading?
Trends towards more integration and intelligence, becoming part of wider onboard digital ecosystem, talking seamlessly with inventory systems, safety management, and voyage planning software.
Creating a unified picture of vessel status and needs enables automation in reporting and powerful predictive analytics.
So smarter at predicting failures?
Yes, imagine sensors all over ship feeding real-time data into PMS automatically. Machine learning algorithms spotting patterns, predicting failures well before humans can detect them.
Moving beyond scheduled maintenance to condition-based or predictive interventions.
Exactly. Maintenance becomes targeted and efficient. Audits become easier with automatic report generation mapping work done directly to regulations.
That saves huge time during inspections.
Other trends?
Cloud-based PMS allows real-time data sharing between ship and shore offices, reduces onboard IT burden, improves security and backups. Mobile access via tablets or phones.
Mobile apps let engineers pull up work orders on site, input data instantly, even take photos, reducing errors from manual notes later.
And AI?
Biggest potential lies there. Processing massive sensor data sets detecting subtle warning signs, predicting failures with high accuracy. Enables highly optimized data-driven strategies, fixing problems just before they happen, maximizing uptime and minimizing costs.
Wow.
To sum up, Well-structured PMS isn't just helpful, it's absolutely essential for modern shipping. Shifting from reactive repairs to proactive management brings reliability, safety, and cost savings.
But success depends as much on technology as culture change on board. Commitment to systematic work, documentation, and teamwork is crucial.
For anyone implementing or improving PMS, prioritize flexible, customizable systems that integrate well with others. Don't skimp on cybersecurity or training. Focus on change management by explaining benefits clearly. Develop in-house data analysis skills to leverage predictive insights fully.
Unlocking power of data is key.
Looking ahead, PMS will be smarter and more connected, almost self-optimizing learning systems integrated into all ship operations, making maritime maintenance safer and more efficient than ever before.
Fascinating evolution with profound questions about future role of human experts amidst growing AI-driven automation in maritime industry and beyond.
Something worth thinking about.